All right, so our next speaker is Dr. John Beatty. He is an assistant professor in the Division of Chemistry and Biochemistry at Texas Women's University. He holds a Ph.D. in Analytical Chemistry from the University of North Texas, a master's in biology, and bachelor's degrees in biology and chemistry from Angelo State University. His research focuses on environmental, analytical, and nutritional chemistry with publications in journals such as the Journal of Physical Chemistry Letters and the Journal of Food Bioactives. One current project focuses on carbon dioxide chemistry, specifically how to convert carbon dioxide into reusable compounds. Before his current role, he served as a senior chemist at PRECILAB and held teaching positions at multiple institutions, including Angelo State University and Park University. He currently serves as the KEM Club advisor and teaches general and advanced chemistry courses at TWU.
Hello, can everybody see my screen? Good. So, John Beatty from Texas Women's University. So I'm going to talk about our project, a little bit about TWU, some of the things we do here on campus, and then our NSF funded project to help us do some of the things that y'all have been talking about. Um, So TWU, we are the largest university primarily for women in the U.S. We have close to 16,000 students right now, and we're about 85 to 90% women, quarter or more Hispanic. So we're MSI, HSI serving institution. And some of the demographics, kind of why I feel like we're in a unique situation here uh, for this project we've been funded for. We, like I said, we're about 90% female. This demographic is a few years old, but it pretty much has stayed flat. As a matter of fact, this year, I think because of the economy and stuff, we've dropped slightly, but these numbers are still good. Notice down here on the bottom right side, about half of our students are first gen STEM students, first generation college students. We have a large in the DFW area. I don't know how many are familiar with that, but we have a large commuting population here. We're on the north end of Dallas and Fort Worth, and a large percentage of our students commute up from Fort Worth and Dallas. So we're kind of in a unique situation. Once we started the project, we started looking at some numbers, and about a third of our total student population actually takes our introductory chemistry course or general chemistry or our principles of chemistry. So we have a large population being introduced to these concepts of sustainability, uh, green chemistry concepts, those types of things. So we think our impact is, it's pretty large. One of the interesting projects that we do on campus, we call our Zero Impact Project. And the idea behind this is we have, universities have a large number of meetings, meals, food is always, offered that gets people to come to the meetings. Well, the idea behind the Zero Impact was that because of those meetings, you have disposable dishes, silverware, those types of things. Well, we wanted to make those types of events have no waste, no food waste, no plastic waste, no waste of any kind. And that's, you can see our Zero Impact team led by Atlanta Taylor. She is one of our environmental scientists on campus. We have a large number of students that help with it. And the idea kind of came from Dr. Middlecamp, you can see there. But, we have one of the, as part of this project, one of the issues is you need manpower because we use, regular plates, silverware, so we need the manpower to help wash those dishes after the meetings. We get the KEM Club I'm the advisor of our KEM Club here on campus, which is our um, um, uh, ACS student organization. and those students volunteer to help wash dishes. We have a number of faculty and students on campus that keep chickens, so they can take any food waste, feed their chickens. So we've actually had a lot of demand for help on campus to make those meetings and things that occur on campus zero impact. So been pretty successful. Here in the Division of Chemistry and Biochemistry, we want to educate socially responsible and civically engaged chemists. 85% of our students, again, are women, and 47% are first generation. We do offer, ACS certified chemistry, biochemistry. We just started a BS in environmental chemistry. It's been pretty successful. Also, along with that, we started a BS in environmental science. So we have kind of two tracks students can choose from, and research intensive master's degree. And our program's been recognized to the amount of civic learning that we incorporate into our program too. Kind of what the students see when they come to campus. We try to start off, introducing social issues like Peter was talking about, sustainability, systems thinking, water quality. Start introducing those green chemistry concepts, and you'll see when I start talking about our project, the funding has helped us incorporate those ideas into our curriculum. Second year students, um, typically, the first year are intro to chemistry, general chemistry. Second year typically take organic chemistry. And a number of those, as part of this project, another number of those experiments we're looking at turning into, for instance, solventless. We've actually converted some of the experiments into what we say solventless, where they don't use any solvents. They basically grind their materials together. How can we save water? You see bolded down at the bottom, air-cooled condensers. For instance, in organic, you might distill a lot. Some of your experiments involve distillation, which you use a water-cooled condenser, which wastes water. And we purchased these air-cooled condensers. They're kind of funny looking, but they're very effective. And since we've been using them, we've noticed in the experiments that we use them for, virtually no difference in the outcome of the experiments using the water-cooled condensers versus the air-cooled condensers. So save definitely a lot of water for sure. Upper division, we offer, environmental analysis. We offer 2 advanced environmental chemistry courses, and we kind of treat those as project-based courses for the students. Uh, where Dr. Salazar, you saw at the beginning, teaches the first half, and I teach the second half. So the students can carry those projects from one class to the other. We offer, seminar courses. We try to invite local um, chemists from industry, companies to come and talk about, you know, issues that they see in their businesses, what kind of um, experience that they're looking for, those types of things. Another thing we've done is what we call the poster show at the mall. And here in Denton, we have a mall, and the idea behind the poster show is to get some of the information we have out to the public. And one of the requirements is, if we're going to have students present their research, or faculty, they had to make the poster converted into more layman terms instead of scientific terms. Uh, and so that's been successful. We've had requests for us to come back every year. This is one of our students, Sarah, here with her grandmother and her great aunt, and she presented on one of her projects that she worked on. And so that's been successful. Again, instead of using jargon, things like that, reaching a larger audience, turn what you're presenting into more layman type terms. We do invite high schools. Of course, these are recruiting events also, but they're also green chemistry events where we teach students about issues with microplastics, green chemistry concepts. They actually build a solar cell out of blueberries and I think raspberries. Uh, we also every summer this is to be the fourth summer I believe we've offered Chem Camp. So we got a Chem Camp coming up in this summer 2025. That little picture on the bottom is from our last year's Chem Camp where we invite high school students participate in a week-long camp where they do, green chemistry experiments. And the idea is if we, and if we get the students interested, then they take those ideas back to their school and hey, teacher, can we do this? Can we do this lab? It's green, it's, sustainable, those types of things. A couple of our partners with this project, Sensors, one of them, and Sensors' main focus is sustainability, science teacher preparation, and focus on undergraduate research. They have, annual meetings, so it's a fantastic organization if you're interested in incorporating civic responsibility into your teaching. Habitable, this used to be a healthy, I always think HBN, Healthy Building Network, but it's Habitable Future now. And they're one of our partners that has given us access to the Pharos database. Peter, in his presentation, said one of the, identified issues was misinformation. And with, the advent of AI and those types of issues, there is a lot of misinformation in Pharos. And I'll show you an example here in a second, as a curated database with hazard information on chemicals, materials, building materials, those types of things. Fantastic database. And our students have access to that. So when we're presenting these concepts and having them look at them, they can look up compounds, chemicals, materials, and assess their hazard. And of course, Beyond Benign, and their teaching and learning connection, bringing everything together. I want you to note at the bottom left that TWU was the 100th institution to sign. And it just so happens, actually, I was in an ACS meeting in Chicago. And if you've been to an ACS meeting, a lot of times those are overwhelming with the amount of posters and talks that they have. And I just happened to be walking by a poster and it was about the green chemistry commitment. I was like, yeah, we want to do that. And got Dr. Cohan, she's a PI on this project. And I believe our chancellor signed the letter saying we're going to commit to to this green chemistry path that we're on. So the title of the project is Green Chemistry: Advancing Equity, Relevance, and Environmental Justice. And you can read through the summary there, but kind of in a nutshell, we want to sort of integrate green chemistry, environmental justice, sustainability in our general chemistry curriculum. And incorporate all those. Obviously, we start here. This is where we want to start out, the 12 principles of green chemistry. When we're looking at designing the labs, this is kind of where I start. Okay, we're using this chemical for a lab, and I have a specific example coming up. I'll show you. Starting here, where do we go from here? How do we design our lab sustainable? Do we need to branch out and go to system level thinking to incorporate these? So my role then, it's kind of interesting. Peter said that chemists and chem ed is kind of uh, late to incorporating these ideas into teaching. And that's kind of surprising to me, where chemists are typically in a unique situation where a lot of chemists like me, I've had industrial experience, I have teaching experience. So you kind of have a view of both sides. And so that was kind of surprising to me when he said we're kind of late to the game. Kind of my role in this project, we want to, as analytical chemists, I want to teach the students basic chemistry and have them have hands-on experience on handling lab equipment, taking measurements, those types of things. I want the chemist to, especially when we went through COVID, I actually worked at a lab, and when everything was going online, the owner of the company specifically said, "We will not hire a chemist that does not have hands-on experience." So we had to essentially redo our interview process and, hey, did you actually do the labs that are on your transcript? What kind of hands-on experience do you have as a student? Those types of things. Um, and the kind of the big idea that I would like to see is we make our chemistry labs self-sustainable, meaning that if we're producing something in one lab, can that be used in another lab, and so on and so forth down the chain. Idea is, at the end, the system feeds itself, where we're reusing materials that we're producing in one lab or measuring or those types of things. And at the bottom here, I like this quote. We actually have a NASA grant that um, that, that that we're working on, but one of the leaders said we need a diverse group with different backgrounds to solve the problems that we have now. And a fantastic quote, and it kind of incorporates everything that we want. And then extending that idea that we want the students themselves to help make the labs that we do sustainable. The project is, the kind of three things we wanted to incorporate: principles of green chemistry. I'm not going to read all those. The principles of environmental justice, and apply those specific topics in chemistry. And actually, I've got one right here, one specific thing we've done this semester. If you look across the curriculum, this is a very common lab in intro chemistry, general chemistry. And basically, we titrate vinegar and we use phenolphthalein as the indicator. Well, before we have the students do the lab, we ask them questions, use the Pharos database to do a little bit of research on this compound. And these are some student responses here that they've, found out phenolphthalein is an organic dye, it's carcinogenic, it bioaccumulates, it's not easily broken down during wastewater treatment. Can we replace it also with something else? Well, two suggestions were curcumin and cabbage. Those are both vegetable-based pH indicators. And a student actually started to calculate how much waste. Typically, if you're not familiar with the titration, right, you add a few drops of the phenolphthalein, and once it's neutralized, since it's neutralized and diluted, you can dispose of it down the drain. Well, if you start adding those few drops up across our labs, and then you start to include the number of universities and communities in the DFW area, I'll show you a picture here. Keep that in mind. But then here at the bottom, at some points of the year, the Trinity River system that runs through the DFW area, the water flow is composed of 90% treated wastewater. So this picture that's popped up is, you can see our Denton, Fort Worth, Dallas triangle. The blue is all the Trinity River basin that runs through these areas. And off to the right there, I showed you the number of students and the colleges in this area. And imagine, if you kind of imagine here, a third of our students do a titration lab that includes phenolphthalein. This is one example, so, systems thinking. And you can kind of think all of these universities, they probably do a chemistry or intro to chemistry that a third of those students probably do a titration that uses phenolphthalein. Can they substitute something in that's not as, not as toxic, not as hazardous, carcinogenic, those types of things? And you can see the number of students here, incredibly large number of students. And the Trinity River flows south of Dallas down here to Palestine. And like I said, when we have no rain here in Texas, Trinity River still flows. Well, that's because 90% of this water that's flowing is treated wastewater. So does that treated wastewater include phenolphthalein that's not been broken down from these labs? And that's just one thing. Here's just a specific example. Obviously, phenolphthalein is right up here on the right, very light pink. Curcumin was one we tried, You can see right here the endpoint was a nice red color. It starts at a yellow in the acid, and they titrate it to the endpoint, which becomes red. The surprising one was the cabbage. Cabbage juice. It starts out as this nice pink color, fuchsia, and then it goes for this picture I took here, students doing the titration. One drop goes from the pink to the blue, so it's very vibrant. Students love it because it's colorful. And the students are titrating a store-bought vinegar, which the label says it's 5%, so they do the titration and calculate the percent acid. But just so pulling some rough data from some of our control groups and some of the groups that are, incorporating the vegetable-based dye, you can see that using phenolphthalein and using the vegetable-based indicator, they get very similar results. So I think this is a good substitute for, phenolphthalein in the lab. Just some other modifications that we've done to our curriculum. We have a copper lab where we take copper metal, dissolve it, take it through a few reactions, and at the end they produce copper metal. So we've had them look at copper mining um, as part of the environmental justice impact. Does mining have an effect? We ask questions to those concerns. We have a KSP lab. It's another titration. We've replaced methyl orange with curcumin, which works surprisingly. As a chemist, I didn't think it would work, but it worked fantastically well. And the methyl orange is um, not environmentally friendly, where the vegetable-based one's perfect. Beer's law. Can we think of this, systems level thinking? We use copper sulfate as a blue colored compound. So they measure the amount using a little UV vis. But could we have them extract the cabbage, measure the concentration in one lab, save that, use that cabbage juice as an indicator for their acid base lab, those types of, system level thinking. And then we've actually had a failure. The calorimeter lab, we substituted, they mix a HCl and sodium hydroxide, and they get a temperature change. We've tried to substitute a couple of things that didn't work. Acetic acid, which is a little bit safer, less hazardous than HCl. So we're still working on that one. And then we try to incorporate them doing research on their own. For instance, on the safety lab, we've added a benzene, as a solvent, and they just basically do research. If you look at the bottom of the slide here, this is from the Pharos database that students have access to. Fantastic as far as, get students having access to the correct information. Oh, I didn't include the tag here. Let me see if I still have it pulled up here. Yeah, here we go. So the students here with the database, you can quickly see, for instance, here's phenolphthalein, here's our curcumin, which is from turmeric, and the cabbage is anthocyanin, the indicator that's in there. But you can line these three up, quickly go through and see what hazards are associated, which one's safer. So this is a kind of a start to some of the misinformation we want students to have the correct information so they're making good decisions on, is this safer alternative? Is it going to pollute? Is it biodegradable? Those types of things. And we're actually starting our second year of this project. The first year the second year was funded. Luckily, our funding wasn't cut from the NSF. We're actually going to do a on-campus workshop. We're inviting, teachers from community college and local universities to kind of talk about some of the things we've done specifically in the labs, in the curricula. So if you want any information on that, you can send me an email. That'll be coming up in July. Advisory board for this project, we've got Dr. Scherdy's here at one of our emeritus faculty here at TWU, and you can read down the list. Dr. Middlecamp. So we have a fantastic advisory board. Also, getting students involved and then they carried this information with them in their jobs. For instance, Alice in the middle there, she was a graduate student with me. She's now a chemist at Oakwood Chemical in South Carolina. She kind of helped us start this project, graduated, and now she's working in the field. And then we have current graduate students that are funded on this project that help us kind of design the labs, do some of the experiments, and those types of things. Ultimately, we want to uh, have a sustainable future. Um, and actually, that's all I've got. If you got any questions, you can email me. There's information. This project is NSF funded, and you can see all of our great partners that we have involved in this project. So I think I went over my time a little bit.
That's okay, no worries. I think we'll just adjust a little bit of the breakout rooms. But thank you, John, for this wonderful presentation,
Yeah.
and telling us all about the wonderful things that you guys are doing.